Okay, so this is chapter 10.1, CFU, on concept 1, sampling distribution of the difference of two proportion. So students should be able to describe the shape, the center, and the variability. In other words, the standard deviation or the spread, right, of the sampling distribution of the difference of the two proportion. So let's dive in. School officials are interested in implementing a policy that would allow students to bring their own technology to school for academic use. There are two large high schools in a town, Granger High and Taylorsville High, each with 1,700 students, 1,700 students. At Granger High, 60% of the students own digital tools that could be used for academic purposes. 75% of students at Taylorsville High own those types of devices. The district takes an SRS simple random sample of 125 students from Granger High and a separate simple random sample of 160 students at Taylorsville High. The sample proportions of students who own digital tools that could be used academically are recorded, and the difference, so the proportion, sample proportion from Granger High, who owns a technology device, minus the sample proportion of students from Taylorsville High, is determined to be 0.07. Okay, so if you read the kind of the symbol of what they need to do, so here, this is the sample proportion, right, of students from Granger High who owns the technology, minus the sample proportion, all right, P hat sub T, and this is P hat sub G. P hat sub T is the sample proportion of students from Taylorsville High that owns the technology. So the difference right now, difference of the two proportion happens to be 0.07. So part A, describe the shape, center, and variability. All right, another word for variability is spread. So you need to kind of consider the standard deviation, right? So center, we're talking about the mean. Okay, it could be median, but in this case, it will be the mean. And variability will be the spread, and we might be looking at standard deviation here, okay? So of the sampling distribution of this. Okay, so what sampling distribution of this means that every time you have a sample of PG, and every time you have a sample of PT, right? The sample proportion. Now, it keeps taking one sample minus this, right? One sample minus another sample, then they keep drawing another sample minus another sample, one sample minus another sample. They keep doing that, and that will produce the sampling distribution. By the way, I forgot to mention about the shape. Shape could be skewed left or right, could be skewed left, or it could be symmetric or bell shape. So to describe the shape, to actually find the shape of this sampling distribution of the difference of two proportion, we need to look at the population proportion, right? So what's the population proportion of students who own technology in Granger? It will be 0.6, right? 60%, change it to decimal is 0.6. Now, the population size is actually 1,700, but the sample size is only 125. And if we look at the population proportion of students in Taylorsville who owns the technology is 75%, put it in 0.75. The population of students in Taylorsville is 1,700. The sample size that was taken was only 160. Now, we need to do the n times p. But in this case, we have two different population, right? We have two different population, one from Granger and one from Taylorsville. We need to do it separately. We need to take the n times ANG, right? The sample size from Granger times the population proportion from Granger equals to 75. And that's greater equals to 10. And then we need to take the NG, the sample size from Granger, times 1 minus proportion, the population proportion from Granger, which is 0.4. And you multiply that by 125, you get 50, which is greater equals to 10. So I just wanted to highlight that this comes from here, and this comes from here. Okay? All right. So how about then we need to do a separate condition check for the Taylorsville population. So NT, the sample size from Taylorsville is 160 times 0.75, right? The population proportion of students who own technology in Taylorsville will be 0.75. And that gives you 120, which is also greater equals to 10. Then we need to take NT times 1 minus PT equals to 40. So the NT here comes from here, and the PT here comes from here. Okay, so all the conditions are met, right? The N times P must be greater equals to 10, and the N times 1 minus P has to be greater equals to 10, but we do it for both population, right? To the two separate population, one from Granger, one from Taylorsville. So we know that now that the shape is approximately normal, right? When we're dealing with proportion, we have to use this, right? We have to use the N times P greater equals to 10, N times 1 minus P greater equals to 10, okay? We don't use CLT here, though. We do not use CLT to find shape for proportion. So now, PG, right? PG minus PT, the population proportion from Granger minus population proportion from Taylorsville equals to 0.6 minus 0.75 is equals to negative 0.15. Then to find the mean of the sampling distribution of the difference of two sample is equals to the same thing, PG minus PT. Why? Because it's an unbiased estimator, right? It's an unbiased estimator. We have to use just the same mean, right? Difference of two mean. How about standard deviation? Now, the standard deviation of the sampling distribution follows this formula. You take PG times square root, and then what's inside the square root is PG times 1 minus PG divided by NG plus PT times 1 minus PT over NT. Right? So you substitute all the corresponding values, and it comes up to 0.0556. So now you found the mean, and now you have the variability, the spread, standard deviation of the sampling distribution of the difference of two proportion. So you can simply write it out. Okay, so describe it. The sampling distribution of the difference of two proportion, right? Sample proportion PG minus sample proportion PT will be approximately normal, right? And the approximately normal part comes from, right? It comes from the condition N times P greater equals to 10, N times 1 minus P greater equals to 10, but you have to do it for both population. So with a mean of negative 0.15 and a standard deviation of 0.0556. All right, part B, find the probability of getting a difference in sample proportion, right? The difference in sample proportions of 0.07 or less, right, from the two surveys. Show your work. So what does that look, for you? When we look at finding the probability, well, since it's a normal distribution, right, it's approximately normal because of all the N times P, N times 1 minus P, for both population, they're all satisfied, and we know it's going to be approximately normal. So we do this, right? Find the probability such that the difference in sample proportion, right, p hat g minus p hat t is less than 0.07. Now, it's interesting because it says here difference in sample proportion. They didn't really specify whether is it Granger's proportion minus Taylorsville proportion or the other way around. So there's no way to say, right? So what the best thing to do is either way, right? Either way. And we put an absolute value around p hat g minus ptg. That means it can go either way, right? It can go either way. And for that to mathematically, it means this. It means the probability of p hat g minus ptg has to be greater than negative 0.07, right? Mathematically, that's how it works for absolute equation, absolute expression. So it's greater than, you just have to add the greater than sign, and then you put a negative sign on the 0.07, and then less than 0.07, right? Less than positive 0.07. So let's draw the normal distribution with the center at negative 0.15. Okay, 3 standard deviation to the left, 3 to the right. And where is the lower bound? Negative 0.07, which is about there. And then the upper bound, which is 0.07, which is about there. And you shade the middle, right? So here, clearly you see where the lower bound is and where the upper bound is. So normal CDF, lower, upper, mean, standard deviation. So the lower will be negative 0.07, upper will be 0.07, mean will be negative 0.15. Standard deviation we found earlier from part A, and put it on the calculator is 0.075, approximately 7.5%. So I'm going to switch gear here and show you how to do it on the calculator. Okay, so calculator, sweet. So second bars, normal CDF. Okay, so the lower is negative. So we need to put the negative sign, not the minus sign, but the negative sign. 0.07. Upper is 0.07, positive 0.07. Oops. Oh, crap. Okay, 0.07. Mean is negative 0.15. Standard deviation is 0.556. Okay. And then voila, 0.075. So approximately 7.5%. So change to, so 7.5%. Now, part C says, does the result in B give you reasonable doubt or give you reason to doubt the study's reported value? The study's reported value, they're referring to the population proportion. So the population proportion for Granger is 0.6, and the population proportion for Taylorsville is 0.75, right? 75%. So does this result, part B, right, 7.5%, does the result give you reason to doubt the study's reported value? Explain. So, assuming the stated proportions for each high school are true, that means assuming that the 60% for Granger High is true, assuming that the 75% for Taylorsville High is true, right, there is a 7.5% chance that we will observe differences between the two sample proportion, right? We observe differences between the two sample proportion as extreme or more extreme. That means it could be, the differences could be less than 0.07 or much less, right, than those observed, right? So in fact, 7.5% is not really very low. You can still accept that, right? I mean, if it's 6%, 5% maybe anything less than 5%, you might say, you might have a reasonable doubt that say, oh, I don't think the proportion were actually accurate or valid, right from the beginning. So 7.5%, it still works.